In stoichiometric calculations, the second type is mass volume relationships. Mass volume relationships means you will be given the mass of one component and volume is asked. Otherwise, volume is given and mass is going to be asked. So generally, when they are giving about the volume you can calculate at STP conditions based on the mole concept. That is, 1 mole of any gas under STP conditions occupies 22.414 liters. Approximately, you can take 22.4 liters. And here, if they are not given at STP conditions, first of all, you have to convert that volume into STP conditions by using P1 V1 by T1 is equals to P2 V2 by T2. You have discussed about this formula in gaseous state, that is states of matter. Yes, equation of state, in the derivation of PV is equal to nRT, you will get this equation. PV is P1 V1 by T1 is equals to P2 V2 by T2. Now see, a simple numerical will say, find the volume of O2 gas required and CO2 gas liberated at STP when 8 gram methane is combusted. So in this question, 8 grams of methane, that means mass of the compound is given, and they are asking volume of oxygen gas required and CO2 gas liberated at STP they are asking. So it's not an issue. STP means very happy. CH4 plus 2O2 gives rise to CO2 plus 2H2O. It is a balanced chemical equation, and a balanced chemical equation is called a stoichiometric equation. Already we were discussing about this. And here, first we will discuss about oxygen required. Look at this. What is given here? 8 grams of methane is given, so underline methane. And they are asking about the oxygen, so underline oxygen. And methane, according to balanced equation, it is 1 mole. Oxygen, it is 2 moles. So 1 mole methane requires 2 moles of oxygen. Methane mass is given, so you write here molecular mass of methane. Oxygen volume they are asking, so you write here 22.4 liters. As 2 moles of oxygen is there, you write 2 into 22.4 liters. So from this it is very clear, 16 grams of methane requires 2 into 22.4 liters. So 8 grams requires how much? Right? 22.4 liters of oxygen at STP is required for this case. In the same question, they are asking you about the volume of carbon dioxide liberated. So we'll see that one. CO2 form they are asking. Methane and carbon dioxide, you see. Methane here is 1 mole. Carbon dioxide also 1 mole. This methane, as in the question, 8 grams of methane they mentioned. So we are writing here again the molecular mass of methane, that is 16 grams. Carbon dioxide is also 1 mole, but they are asked about the volume of carbon dioxide, so we are writing at 22.4 liters. 16 gram of methane gives 22.4 liters of carbon dioxide according to this equation. So 8 grams gives how much? It's very, very simple. 8 into 22.4 by 16 is nothing but 11.2 liters of CO2 at STP. So this type of calculations are called mass volume relationships, and in this kind of cases they will give you mass and they can ask you about the volume. Otherwise reverse, they will give you the volume and they will ask you about the mass. Conditions, you are going to answer only about the STP conditions, and if not STP conditions, you have to convert that by using P1 V1 by T1 is equals to P2 V2 by T2. Right? I think you got this one. All the best.